Hi, I'm Dave Lerman, Chairman of Steel Warehouse Company. I was a part of this project where we built a state-of-the-art pickling line that can handle up to 1-inch thick material, up to 50,000 yield, up to 100,000 yield material, up to ½ inch, up to 85, 90,000 pound coils. Truly a state-of-the-art piece of equipment, and I'm going to take you through a walking tour of the facility. Right now I'm facing a storage facility that's right beside our pickler, where we can put raw material in and feed the line through two 50-ton cranes that occupy the storage building, as well as take the exit side of the line and bring the coils that are finished and ready to be packaged at the other end of this packaging building. The capability for this line is somewhere around 35,000 tons a month, and so we felt the need to create the capacity on the storage side of this thing as well, make sure we did not choke down the production. So what you see here is a line of conveyor that brings the coils from the raw storage building into the bay that our pickler is in. So now we're going to go to that bay where the pickler, and we're going to walk through the pickle line together. We're now here at the entry end of the line. To my right are coils lined up on an entry conveyor that allows us to make sure we always have steel ready to get up on the line and run for production purposes. What you see in front of you is the Uncoiler, where we take the coils in a coil car and move them from the conveyor line into the Uncoiler itself. The Uncoiler opens up, the coil comes in, and we grab it on the inside diameter and get ready to thread the line. Again, this line is 50-ton capability, actually a total of 45-ton maximum, 50-ton cranes, and we thread the coil here. This giant structure over the top of the Uncoiler is necessary as we get into these very high-strength coils that have a tremendous amount of kickback to them. And so we have to hold the coil in place and make sure it doesn't spring back on us as we start to thread the line. The Uncoiler itself is driven by two 200 horsepower motors through the gearing and the hold downs, again, to be able to thread a line where the steel is so thick and strong it's going to fight you. So we have to be able to have that horsepower that can push the steel into the line. Next, we're going to move into the threading part of the line. Again, once you get the coil started, you have to peel the end, flatten it enough to feed the line. And now we're going to show you how we do that. What we have here, again, is a site where we've put the coil on the Uncoiler, and now we have to thread it up. We have to take the coil set out of the steel, which we get underneath the end of the coil and get a peeler underneath it that brings the coil up out of the coil set enough to run it into a set of pinch rolls. The pinch rolls grab that end of that coil together with the horsepower on the Uncoiler to push the coil forward. You can see the size of the set of pinch rolls and the strength of the peeler to again reflect the strength of the steel that we're dealing with as we run it through our line. The next thing we see is a 3-roll breaker. We break down the natural roundness of the coil as it comes off the coil set and try to get it flat enough to, again, continue to feed the line. Because we're dealing with such strong material and thick material, you can see that the size of all the rolls are extra big and extra strong, all hydraulically controlled. A little hold down roll to make sure the steel does not get out of shape and bang into something. And here we bring the coil across. Incidentally, here is a giant number of the controls we have on the line so that the operator at this end can see what's going on throughout the line and all the push buttons and controls that he uses to thread up the line. A crop shear that can get rid of a coil end that's bent up or a lead end coil piece so that we can continue to feed the line as well as possible. Another set of pinch rollers to continue to feed the line into a coil flattener, again, built giant size to take the coil set out of the steel, so as we push the steel through the line and continue it on a pull-through basis, we make it flat enough to make sure it threads through the line in good shape. A lot of high pressure air to blow off any excess scale so that we're not accumulating the scale on the rolls, doing damage to both the rolls and the steel with the excess scale, blowing it off before it does damage to the surface. Again, a second crop shear where we cut small pieces and take it off with a magnet, bring it over to a cutting device here for samples to check to make sure that the steel is its proper yield strength and grade as a quality check for the steel itself to make sure it matches the requirements. As we go from here, we enter the first pickle tank. A squeegee roll in front and at the end of all the tanks to keep the integrity of the acid not going from one tank to the other for a long period of time. What you are beginning to see as the camera moves around are the acid tanks that clean the steel. We're using hydrochloric acid in different percentages, and there's 3 60-foot tanks in this line. Between each of these 3 tanks are sets of squeegee rolls, hard steel rolls covered with rubber to try to keep the integrity of each tank separate. At the top of these tanks you see a series of pipes. These pipes are there to absorb any air coming through, to keep the air within the plant clean. We have a negative pressure in these tanks, so there's a big suction system that goes through an air cleaning system to take any acid out of the air as it gets sucked through the system before we expose that air to the outside. We're starting at the first tank. This tank has the least concentrate of acid, the best concentrate of the cleanest concentrate of acid starts at the other end of the line, the last 60-foot tank. There we put in fresh acid, approximately 13% of acid compared to water. It's all heated to 190 degrees. This whole line is heated in different sections from some big boilers, from an outside location next to the line, and the acid is, that acid water concentrate is heated through a series of heat exchangers that, again, are all acid-proof pump that pump the fresh acid into the far tank. As the steel runs in that direction, the acid moves in the other direction, goes into storage tank and reheat tank, brought into the second tank, and then that process is returned into here, the third tank. So by the time the acid concentrate gets here, it's not nearly as strong, and it has a lot of iron in the acid itself, which makes it less effective to get rid of the scale. So as it moves forward, this tank does a big job of heating up the steel to match the temperatures you need to really get steel clean in the pickle. The acid tanks, all three acid tanks, are steel tanks on the outside. They are covered with rubber coating on the inside of the tanks to protect the steel from the acid. And then the rubber coating inside the tanks are covered by shaped limes, are covered by granite. Granite is shaped inside, it's sort of a V shape. The depth of the acid here in the center is about 17 inches. The granite is so hard that as you feed the steel through the line, the steel runs across the top of the granite with some lubricity from the acid-water combination, so you're not scratching the steel, and the steel is submerged in this 17 inches of acid. As it goes through the tank, there's a little ramp at the end of each end of the tank that takes the steel back up to line size and takes it through a set of pinch rolls. So this happens in each of the tanks. Again, squeegee rolls between the tanks to keep the integrity of each tank proper. One of the things you see over here is the air cleaning system. We're now at the exit of the acid tanks. Again, this is the cleanest acid in the third tank. So at this point, the steel is pickled, clean, except we want to make sure we've rinsed off any acid in the steel. Any acid that stays on the surface will create problems in that surface. So the steel is entering a water rinse section. A double squeegee roll here to make sure we get as much acid off the steel before it enters the rinse section as possible. But then again, this system for cleaning all the acid off with water system actually follows the same lead as we did on the tanks, where the cleanest water is in the far exit section and the dirtiest water is at this section where we start the cleaning process. So the last thing the steel sees is the cleanest water. This water is specially treated. It's called RO system. So we use a special water treatment on all the water that gets used in this cleaning system. The water here is also heated, again through the same steam power that comes from boilers that create the steam to heat the water just like it heats the acid. Here the steel is exiting the rinse section, the water rinse section, okay? And as it does that, it goes into this system and hot air starts flowing through here and blows it dry. What we hear now is the drying system kicking on. Hot air on this dryer right in front of me as the coil exits the rinse section. Again, a big heavy set of pinch rolls, squeegee off any of the water possible, and then as the steel is just now starting to come through. Here comes the steel, the lead end that's dropped off of the coil. It's now going through this dryer. Again, a set of very heavy pinch rolls in case it's needed. Keep the steel flat. You can see it's a beautiful gray color. It means we pickled it nice and clean. We're making sure there's no water carryover. The water rinse makes sure there was no acid carryover. Now we have a clean, dry, pickled piece of steel coming down through the line. Okay, this piece right in front of me is again another crop shear. This conveyor table comes up out of the way, so if we have a bad leading edge to the coil or a bad exit edge to the coil, as it comes through, we can crop those pieces off, and it drops down into this little car underneath and gets carried off the line so that we're not wrapping up bad steel in the coil. We're now headed into the inspection pieces in the line. Right in front of me is an X-ray thickness gauge that moves in and out of the line. And right now it's in the middle of the line recording the thickness down through the center of the coil. It records the thickness measurement from one end to the other of each coil, and then we have a record of that. Next to that inspection device is a set of digital cameras that are looking at the quality of the surface and categorizing any issues there are on the surface, such as pits and scratches and the degree of which those pits or scratches occur. The unit is called a Parsitech, and again, we have a computer recording of everything that these digital cameras pick up, so we have a record of the surface conditions of the steel to show you on an after-the-fact basis if there are issues, where the issues come from. We are now exiting the rinse section of the pickle line, and then to make sure that we're not carrying over any water that might create rust later, we're blow drying the steel with hot air from the top and bottom to get rid of any water that's on the surface of the steel and make sure the steel is dry at this point. The conveyor rolls are all covered with rubber to make sure we never scratch the steel on the bottom as we're running it through the line. Okay, what you see now is a personal inspector who's also using his hands-on, double checks the thickness with a micrometer, rubs the surface to see if there were surface issues there, records a lot of that information for each coil to feed back to the customers so they know exactly what we see in that coil as it gets pickled. He records it again on our control system, so it's all in writing. What we see right in front of me here are some giant pinch rolls that hold tension. So as the coil comes through and we want to wrap that coil tight on the recoiler, we have to have some tension that tries to hold the steel back as the recoiler tightens that steel up. There's two 400 horsepower motors and there's motor generators, and we get controlled braking action from this section. I'm now in the main operator console with the head operator of the whole line, who can see all parts of the line as he runs it and what's going on throughout the entire line. And the piece of equipment that's right in front of him is an oiling device. It's an electrostatic oiler, so using electrostatic controls, we're able to control the thickness of the oil that we put on the steel, from heavy oil to light oil, and that just gives that customer, again, more control over the quality of the product coming out. The line is just now coming to an end of this coil, and we're going to catch that on the recoiler again as we go back. Thanks. Yes, sir. We're now at the exit of the line. The lead end of this coil is now on this device that threads the recoiler. So we hold that steel up at a just proper angle to feed into the lock on the recoiler. So we're now threading the recoiler with the lead edge of that coil. We are some 300 feet away from the start of this line where we started the coil, and now we're at the exit end of the line. We just threaded the lock on the recoiler with a big outboard bearing and a big arm that holds it in place. There's a tremendous amount of pressure that will be put on the steel as we exit. Note how the recoiler is now taking the coil, starting to recoil it. The table moves out of the way, and we start the recoiling process. At the exit of the coil, the recoiler operator's right here, and he's part of this whole system with the head operator, as we come to the end of the coil, we exit some of the equipment before the end of the coil comes through to make sure we don't damage that equipment. The X-ray control device, the oiling device, moves out of the line to protect from damage, and then we finish coiling up the end of the steel. And so we're going through that process right now, carefully. A hold down device comes down and holds the end of the coil down so that it doesn't get loose. And now the exit operator is bringing the end of that coil through, and he's pinching it with the hold down device. And he's going to bring that end around carefully. It's going to make some noise as it comes all the way around, and he's going to hold the end of that down by bringing it around to the bottom and pinching the end of that coil with the coil car underneath it. Double checks to make sure he's got the end of the coil pinched. And then he proceeds to what needs to be done to get the coil off, which is he has to pull the arm out of the way, shrink the diameter of the shaft so that there's room to pull the coil off the end, and then he will pull that coil off, put that coil on a horn that's right behind us where he puts the bands on the coil. All the plumbing that's in the line, storage tanks for acid, storage tanks for the water, the clean acid, the acid after it's neutralized, the water as it goes through the system to make sure it's neutral and doesn't carry any acid out on the exit side of the water system. They're all in a pit so that if any of the tanks or all the tanks break for some crazy reason, all those materials are contained in that pit. There are also pipes from these buildings here. One building carries all the controls separately, and one building carries the boiler system that creates the steam that heats the line. And so the steam goes into pipes that heat the acid, that heat the water, and even heat the air that blows dry the steel.